All right, so in this first lesson of Learning Guide 2, we're going to do our introduction into derivatives. The good thing is if you've kind of finished Learning Guide 1 already, you've seen the very intro into derivatives, which is the first principle. And that was the formula, the kind of crazy big looking formula that we saw just in the very last lesson of Learning Guide number 1. That formula looked like this guy, and we said that basically our slope is equal to that formula. Now, the cool thing, and I'm going to mention this about a million times throughout this learning guide, is that derivative is slope. So immediately we can use this formula the exact same way as what we've been doing already. And again, this is on your formula sheet and it's called your first principles formula. So in this first lesson, what we're going to do is really practice finding our derivative using this formula. This, guys, this sheet is just kind of a review. So basically you can go through that and compare that with your Learning Guide 1 notes. Here, if I skip to this guy, it's saying to determine the derivative function, this, which is a symbol which I'll get into in just a little bit when we're down here. This is a symbol for derivative, so we can find the derivative using first principles, again, using this formula here. The act of taking the derivative is called differentiating. This is just a keyword that I wanted to make sure you guys are aware of. Some of your questions are going to say differentiate the following, and that literally just means find the derivative of the following. It's saying there are several notations used to represent the derivative. The most common ones we're going to use is this one and this one. And then when we get a little bit later on, we're going to be using these guys in further learning guides. So basically for right now, we're going to say f prime of x or y prime, or again, just derivative. If I want to go through the first example here, again, it's saying find the derivative. We're going to use that first principles formula. So we've got our function 3x squared, and it's saying find the derivative and slope, basically the same thing, at x equals 1, 2, 5. So we're going to use this formula and basically come up with an equation that will give us a derivative at any given point. So let's figure this out. So first of all, we know our derivative is going to be equal to the limit as h approaches 0. And if we look at our formula, we've got f of x plus h. Now remember, I don't want to put in any specific x values just yet because I'm looking at a very general equation. So I'm going to leave x in my equation. So I'm going to say f of x plus h minus f of x all over h. And we're going to fill in our blanks here. So I've got the limit as h approaches 0. Now again, our function is this guy here. So remember, that means that I'm taking my function and my x value and I'm replacing it with x plus h. So that's going to be 3 times x plus h squared minus my function. So my function is f of x, so that's just going to be 3x squared all divided by h. So just make sure, take a quick look over that, make sure that that all really makes sense to you, because that for a lot of students is one of the parts that they get stuck on. Next, we're going to just try and simplify this. Okay, now obviously I've got x plus h being squared. That means that I'm going to need to FOIL this out. So I'm talking this guy right here. So basically, I've got 3 times, and if I FOIL that, again, if I'm just kind of taking some shortcuts here, just think that that's like x plus h times x plus h. That's just going to become x squared plus 2xh plus h squared minus 3x squared all divided by h. Now remember, with limits, you put in that value of your limit as soon as you can. We still obviously cannot put in h equals 0 because we have that h in the denominator. So let's go ahead and simplify. We're going to expand this. So I've got the limit as h approaches 0, 3x squared plus 6xh plus 3h squared minus 3x squared all divided by h. And what you're always, or what you should always notice, is that things are going to start to cancel out once you get to this step, here and here. So I've got limit as h approaches 0, 6xh plus 3h squared over h. And now if you look, every single term has an h in it. So technically what I can do is just divide everything by h. So that's going to allow me to say the limit is going to be 6x plus 3h. Now remember, the minute we can put in that value, we do. And in this case, that's going to be 6x plus 3 times 0, which is basically just 6x. So this is my derivative equation. This is now a formula to find the derivative f prime x at any given point. So that's awesome. So it's now a formula to find the derivative at any given point. So what does that mean? Well, if we come back up here, it said x is equal to 1, 2, and 5. So those are the 3 points that I actually want to find the derivative at every given stage here. Or remember, this also means slope, right? So I'm looking for the slope at any given stage. So how this would go, I've got my f prime. Now of 1 is going to be equal to 6 times 1, which is 6. The next point, f prime of 2 would be 6 times 2, which would give us 12. F prime of 5, 6 times 5 is going to give me 30. So all of my slopes or derivatives at every given point are given here as 6, 12, and 30. Now, some of you might be like, okay, I can find it, but I don't really know what it means yet. Don't worry. When we start to get a little bit more comfortable with how to use this formula, then we're going to talk about the application of this and, kind of take a look visually at what this represents. So let's again just kind of keep practicing this formula. It's saying using first principles. So again, same thing to find the derivative of the following functions. So I've got my formula written over there. So I've got my function in terms of x plus h, first of all. So my function in terms of x plus h. So that means I've got x plus h squared minus 7. And then I'm subtracting, and don't forget to use your bracket here, my original function, which is just 4x squared minus 7. And all of that is going to be divided by h. Now the same thing, you'll just realize that we kind of copy and repeat the same thing over and over again. Again, I need to expand that, FOIL it out. So that's going to be 4 times x squared plus 2xh plus h squared minus 7. And then minus 4x squared plus 7, all divided by h. So just lots of algebra here. And remember, oops, I forgot to write in my limit as h approaches 0. So obviously we can't put in 0 yet. So let's keep going. Going to expand 4x squared plus 8xh plus 4h squared. And then right away, I can just kind of cancel those guys out. Minus 7 plus 7. And then minus 4x squared, all divided by h. And the cool thing is, again, like I keep mentioning, you're going to notice that things will cancel. And if they don't cancel and you're still left with an h on the bottom, probably you did something wrong. So just go back and double check your algebra. So this guy and that guy are going to cancel. And then just I'm going to speed things up a little bit. And I can also divide everything by h. So that means I'm going to have 8x plus 4h. Now remember, this is all as the limit of h approaches 0. So once I can plug in that h is equal to 0, this is going to become 4 times 0. So we're just going to be left with 8x. Now remember, that is our derivative. This is basically, this question is just saying, find the derivative. So the derivative of this is this. And that again, just if you can remember from the last question, is basically a formula allowing us to find the derivative or the slope at any given point on our graph. As always, I really do encourage you guys to try these examples on your own and then, like pause and then just double check. The next ones are a little bit different. They're a little bit more intense, and this is kind of what you guys are going to be seeing a little bit more in your assessments. So it's saying use first principles to find the derivative, which we've just been doing. Then use this derivative to find the slope of the tangent at the specified point. So this is kind of going back to that first example we did, just a little bit trickier. And then write the equation for each tangent. If I ask you guys, write an equation for a tangent line. First of all, what you want to identify is what kind of line is a tangent line? Is it a curve or is it a straight line? Well, it has to be a straight line because otherwise we can't find the slope of it. And remember, the equation for a straight line is mx plus b. So this is really important that you guys remember that. So if any of these questions is asking for you to find the equation of the tangent line, right away you know your answer should be in the form y equals mx plus b. So there's lots and lots of information that we have to figure out in this question. First, however, we obviously need to find the derivative. Now remember our formula. So I've got my f prime of x is going to be equal to the limit as h is approaching 0. And we've got x plus h minus f of x all divided by h. So, and this one, don't forget, is on your formula sheet. So now let's figure that out. We've got our limit as h approaches 0. Okay, my function in terms of x plus h. So it's going to be 5 times x plus h squared minus x plus h minus, and then just, again, don't forget your bracket, 5x squared minus x, all divided by h. Now we need to expand and simplify. Sorry, guys. Okay, expand and simplify. So I've got 5 times x squared plus 2xh plus h squared minus x minus h minus 5x squared plus x, all divided by h. Now we can go ahead, expand and simplify. We've done this quite a bit. So that's going to be 5x squared plus 10xh plus 5h squared. And if you notice, minus x and plus x, we don't even have to rewrite that. It's gone. So I've got minus h minus 5x squared, and all of that is going to be divided by h. Now again, at this stage, remember I keep saying things should cancel, and they do. 5x squared and 5x squared. And then we also can notice that our h's are going to simplify. So this is gone, this is gone, this is gone, and that is just going to become a 1. So let's rewrite that. The limit as h is approaching 0, we're left with 10x plus 5h minus 1. Now remember, h is equal to 0. So this is just going to become 10x minus 1. And that, recall guys, is our slope for our derivative formula. Okay? So that's the first step. First out of 3. So if I go back up to the question, it's saying find the derivative. Okay, check. We found the derivative. Use the derivative to find the slope of the tangent at the specified point. So that's our point right there. We've got our 1 and 4. Now you might think, okay, well, what do I have to use? I've got an x value and I've got a y value. So 1, 4, and that's my x value and my y value. Well, the only one that's really going to apply into our equation is obviously the x value, right? Because that's all that we have. We don't have a y in there. So this is our derivative. We want to find our slope when x is equal to 1. So let's do that. I've got my derivative or my slope. I've got 10 times 1 minus 1. So that's obviously going to give me 9. So I know that 9 is my slope. So remember, I'm going to say it a million times, slope and derivative are the same. So I've got my slope there. So now we've done the second part. It's saying, okay, use the derivative to find the slope. Excellent. Last step here, it's saying write the equation for each tangent. So I want to write the equation at this point. Now remember, I'll just do this all in a different color. The equation of our tangent line has to be in this form, y equals mx plus b. Well, right now we actually know quite a bit of this information. We already have been given the point 4 and 1 for x and y. We already know our slope, which we just found to be 9, but what we don't know is b. We don't know what our y-intercept is. But obviously we can easily solve for it using this formula. So I've got 4 equals 9 plus b, so b is going to have to equal -5. And when we put that all together in our equation, remember we always leave our x and y as they are, but our slope, there's only 1. And our y-intercept, there's only 1. So our final answer would be this. So we found our derivative, we found the slope using that derivative at a given x value, and from that we were able to come up with an equation of that tangent line at that specific point. Now there's one other example of doing these. Again, I really encourage you, just pause it, try it yourself. But let's go through, and again, we're going to do the same kind of steps. So our derivative, we'll just write out our formula. The limit as h approaches 0, I've got f of x plus h minus f of x over h. Let's fill that in. So again, my function in terms of x plus h, so this is going to become x plus h plus 3 squared minus my function x plus 3 squared, all divided by h. So you can see the equations are getting a little bit trickier, right? Well, in this equation, we're not going to take a shortcut to find the, to expand the square. So let's just write that all out. So x plus h plus 3 times x plus h plus 3. And then we can minus, and that we can simplify, that x plus 3 squared. We know that that's going to be x squared plus 6x plus 9. And all of that is being divided by h. Now again, it's just kind of simplify, simplify. So we've got our limit as h approaches 0. We can FOIL this all out. So we've got x times x is x squared plus x times h plus 3x. Next one plus x times h plus h squared plus 3h plus 3x plus 3h plus 9. Big long one. And now we've got minus, I have to fit it in here, x squared minus 6x minus 9, because I'm just applying that negative to everything in there. And then divided by h. And now this is the best part. We get to go through and simplify and see what's going to cancel, what we're going to be left with. So I've got x squared and x squared are going to cancel. I've got 3x plus 3x minus 6x, so those are going to cancel. I've got a plus 9 and a minus 9, so those are going to cancel. And then if I just kind of simplify what's left over, h approaches 0, I've got xh plus xh, so 2xh, so those guys are gone. I've got my h squared, and then I've got plus 3h. Oh, I'm sorry, plus 6h. I forgot this little guy over there. So plus 6h. And all of that is being divided by h. So take your time when you do this. Obviously, don't make little mistakes like I just did, or if you do, just make sure you check them. check it over before you're good. Because at this stage, this is kind of a good stage to be at because you can kind of check your h's. Again, that denominator should always cancel out. So let's do that. All of those are going to be gone. So this is now going to be the limit as h approaches 0 of 2x plus h plus 6. Well, if h is going to be equal to 0, we know our derivative. I'll write that actually out here. So our derivative is 2x plus 6. So this is kind of our derivative formula. This is how to find the slope at any given point. Now, the next stage of the game, remember it said find the slope or find the equation of the line at 225. And remember that's my x and my y value. So we want to find the slope when x equals 2. So let's do that. 2, I've got 2 times 2 plus 6. So we've got 4 plus 6 is 10. And remember that that is equal to our slope because slope and derivative are the same. The last step here, remember, was to find the equation. And our equation of a tangent line is always going to be in this form. And luckily, we have, again, just like the last question, we've got lots of the information. We've got 25 and 2. So I'm going to put 25 here. I know my slope is 10. I know my x is 2. B is the only thing that we need to solve for. So B is going to be equal to, 12. I'm adding them together, sorry. 10 times 2 is 20, and then we're going to subtract 20 from both sides, so B is going to be equal to 5. And then we can combine all of that into our equation. So I've got y equals mx plus b, so remember y and x stay as they are. 10 is my slope, and 5 is my y-intercept. This is going to require a lot of practice, guys. So I've kind of gone past it here. Here, page 75, just make sure, please, practice, practice, practice.